Voyager reached the edge of the solar system and ran into something people nickname the 50,000-meter Inferno wall. And the impossible part is simple. It didn't melt. It didn't even stop transmitting. Even worse, when that boundary hit showed up in Voyager's data, Earth only learned about it roughly 17 hours later because Voyager was more than 120 AU away, around 18 billion kilometers. NASA JPL, Stone et al., 2013. If this were Earth, 50,000 degrees would vaporize metal. But Voyager kept talking, like the wall is hot on paper and cold in reality. So either physics broke, or our intuition about temperature is the thing that gets burned. Here's where it gets crazy. The solar system doesn't end with a clean line. It ends with a stack of invisible zones, termination shock, heliosheath, heliopause, interstellar space, like layered storm fronts at the boundary between the Sun and the galaxy. Stone et al., 2005, Stone et al., 2008, Stone et al., 2013. And the Inferno wall isn't a glowing barrier you can see. It's plasma physics you can only detect by watching particles behave differently. The normal science starts at the Sun. The Sun constantly blows a stream of charged particles called the solar wind. That wind drags the Sun's magnetic field outward and inflates a giant protective bubble around the planets called the heliosphere. But the galaxy isn't empty. Outside, the heliosphere is the interstellar medium, thin gas and magnetic fields between stars. When the expanding solar wind finally collides with that surrounding medium, it forms boundary layers. First, the termination shock. The solar wind goes from supersonic to slower and hotter, like a sonic boom made of plasma. Voyager 1 reached it in 2004, Voyager 2 in 2007, Stone et al.'s 2005, Stone et al.'s 2008. And right away, the story gets unsettling. They hit it at different distances, which means the Sun's bubble isn't symmetric. It's squashed and shaped by forces outside it. Beyond that lies the heliosheath, a turbulent region of stirred-up solar wind. It's not empty. It's messy. And then comes the real border, the heliopause, where the Sun's particles drop away and interstellar particles take over. Voyager 1 crossed the heliopause in August 2012, and NASA confirmed and announced it in 2013 after the evidence locked in. Stone et al., 2013. This is where things get strange, because the word temperature is a trap. In near vacuum, temperature often means particle energy, not how much heat gets dumped into a spacecraft. Heating is about collisions, how many particles hit you per second and transfer energy. And out there, matter is unbelievably scarce. That's why the Inferno wall can exist as a number and still behave like cold space. But Voyager's crossing wasn't accepted on vibes. It became a detective case. Voyager 1 and Voyager 2 launched in 1977 as planet missions. Decades later, they became boundary scouts. The solar wind thinned. The environment got twitchy. It felt like approaching weather you couldn't see. Then came hard milestones. In 2004, Voyager 1 hit the termination shock, and its instruments watched the solar wind slow, heat, and change character, proof the heliosphere has a real structure, not just a concept. Stone et al., 2005. In 2007, Voyager 2 hit the shock too, but at a different distance, another hint the heliosphere is dented and uneven. Stone et al., 2008. Voyager then crawled through the heliosheath, and scientists around the world watched the particle data like a heart monitor, waiting for the signature of the true boundary. In August 2012, Voyager 1 saw solar-origin energetic particles drop fast, while galactic cosmic rays surged, like someone opened a door to the galaxy. Stone et al., 2013. That looks exactly like what you'd expect if you'd crossed the heliopause. But there was a cliffhanger. The magnetic field didn't do a clean, dramatic flip some people expected right away. Debate erupted. Had Voyager truly left the heliosphere, or had it entered a weird in-between zone? And then the worst twist. Voyager 1's main plasma instrument had died years earlier. You might be thinking, so they can't prove it. Stay with me here, because this is where the science gets brilliant. Scientists proved the crossing using 3 clues. Count them down. 3. Solar system particles dropped sharply. 2. Galactic cosmic rays rose and stayed high. 1. Plasma density jumped to values consistent with interstellar space. Stone et al., 2013. Clue number 1 was the genius move. Don Gurnett's team used Voyager 1's plasma wave subsystem. When shock waves from solar eruptions reached Voyager, they made the surrounding plasma ring with oscillations. The frequency of those oscillations reveals the plasma density, like tapping a wall and identifying the room behind it by sound. The densities matched interstellar plasma. That sealed it. Voyager had crossed the Heliopause and entered interstellar space. Gurnett et al., 2013. Now we can finally explain the 50,000 liters Inferno wall without breaking physics. In the outer heliosphere and Helios Heath, particle populations can be extremely energetic, often described in popular summaries with temperatures of tens of thousands of Kelvin, depending on which particles and region you mean. The number is about energy per particle, but the density is so low that heat transfer is tiny. Analogy: an oven burns you because you're surrounded by trillions of molecules, constantly colliding with you. The heliopause region is more like a near-empty room with a few ultra-fast ping-pong balls. Those ping-pong balls have high energy, so the temperature number sounds insane. But there are so few of them that almost none hit you, so almost no heat transfers. That's why Voyager doesn't melt. The horror isn't fire. It's how wrong our intuition is. And here's the personal stakes reveal. This boundary marks the edge of a massive space shield. Inside the heliosphere, the solar wind helps modulate how many galactic cosmic rays reach the inner solar system. Outside, the galaxy hits harder. Voyager didn't just find an edge, it found where shielding changes. Just when you think the case is closed, the second twist arrives. Voyager 2. In November 2018, Voyager 2 crossed the Heliopause 2, and unlike Voyager 1, it still had working plasma measurements, allowing scientists to directly watch the solar wind fade at the boundary. Stone et al., 2019. Nature Astronomy, 2019. That confirmed the crossing with a different set of tools. But Voyager 2 crossed at a different distance, and the transition behaved differently. Meaning the heliosphere isn't a rigid bubble. It's a living boundary shaped by the interstellar magnetic field and the Sun's 11-year cycle. It breathes, it dents, it shifts. Then comes the controversy layer. For years, many expected a classic bow shock ahead of the heliosphere, like a boat's shock wave in water. But IBEX results suggested we might not have a strong, clean bow shock in the simple sense, possibly more like a gentler bow wave depending on conditions. McComas et al., 2012. That means the Inferno wall might not be one wall at all. It may be overlapping effects. Hot heliosheath plasma, magnetic draping that controls which particles cross, and neutral atom charge exchange interactions near the boundary, changing with time and direction. So what do you think the Inferno wall mostly is? A. Hot heliosheath plasma, B. A magnetic barrier controlling particles, or C. Neutral atom chi charge exchange effects. And what measurement would convince you? Because this matters. Galactic cosmic rays are a serious issue for astronaut health, deep space electronics, and future Mars missions. The heliosphere is part of Earth's long-range radiation environment. And zoom out even farther. Every star with a wind likely carves an astrosphere. Understanding ours gives us a template for how other star systems protect, or expose, their planets, tying Voyager to exoplanets and habitability science. The hopeful part is, Voyager is still out there, still transmitting with fading power, still turning cosmic guesswork into measured reality, one quiet radio whisper at a time. And the next generation is lining up. IMAP will image the heliosphere using energetic neutral atoms, and future interstellar probe concepts could sample the boundary in multiple directions, turning our two needle path crossings into a real 3D map. Voyager didn't find a wall of fire. It found a boundary where physics breaks your intuition, where 50,000 degrees can be real and still not burn. And that might be the scariest discovery of all.